Hi guys, welcome to the next lecture. Today we will be talking about absolute value equations. So let me recap what is absolute value or modulus. Modulus x, when x is greater than or equal to 0 and when x is less than 0, could be defined in the following manner. So when x is positive, it's greater than or equal to 0, whatever is inside these two bars, modulus bars, comes out as it is. And when x is negative, minus of it comes out, and that's how you get your absolute value. Now we are interested in the modulus equations. So equation means that you're equating with something, right? If you have modulus of x and you equate it to some number a, how do we solve for it? Let's try it out. Now, there could be three scenarios that we will be working upon. This number a could be positive. This number a could be negative. This number a could be equal to 0. Accordingly, what solutions, how many solutions for that matter, can we have? Case 1, when a is less than 0. What will modulus of x equal to a look like? Well, I'm going to give you some insight, first of all, graphically. Now, the graph of modulus x moves something of this sort. It's 45 degree, V-shaped graph, right? Which will cater to the points like -1, 1, -2, 2, 0, 0, 1, 1, 2, 2, and so on and so forth. Okay. Now, what are we saying? We are saying modulus of x equals to a. So this equation involves mod x, and it involves a, the number a. So a is negative in this case. A is negative means it is somewhere here. A negative means it is somewhere here. Function y equals to mod x looks like this. And let's take it as a different function. Y equals to a looks like this. What do we want? We want these two functions to be equal. Is that happening anywhere? Absolutely not possible. That is because modulus of x is always greater than or equal to 0. How can it be negative? It cannot be negative at all. So therefore, the situation that we are dealing with, mod x equal to a when a is less than 0, has no solutions to it. Not even a single solution possible, because if you take them as two separate functions and then equate them, you will realize y equals to a is not intersecting anywhere with y equals to mod x. That's not happening at all. But when we have a equals to 0, modulus of x graph is again this V-shaped graph, y equals to mod x. Now consider the second graph, which is y equals to a, and a is equal to 0 this time. If a is equals to 0, so this is the line that is x-axis where y is equal to 0, right? Y is equal to a, which is equal to 0. Well, we do have an intersection with mod x here. And what's that intersection? This is where this intersection is. The intersection is happening when x is equal to 0. And in fact, y is also turning out to be 0. So you have a unique solution. There is a unique solution, and that is x equals to 0. So mod x equals to a, which is equals to 0, gives you a unique solution, x equal to 0. Okay. Now let's talk about a case for mod x equal to a when a is greater than 0. The graph of modulus of x will again remain the same. So it's going to be a V-shape. It's going to be a V-shaped graph. 45 degree here. And this time a is positive. So we will consider the graph of y equals to mod x and the graph of y equals to a, where a is a positive number. A positive number y equals to a would be somewhere here. So V-shaped graph is the graph of mod x, and this graph that you see is y equals to a, because a is greater than 0, it's somewhere here. Clearly, I can see that it's cutting the graph of mod x at 2 points. What are these 2 points? Well, these 2 points, if you see, if a is here, then this length is a, right? So this point is y equals to a. It turns out to be minus a, because this height is a. And this point is point A. So which means that mod x equal to a, where a is positive, this will happen when x is either minus a or it is a. In both the scenarios, I am going to get the same thing. And well, yes, by the definition of it also, if you look at the modulus of minus a is the absolute value that comes out. If you look at the modulus of a is the value, absolute value that comes out, right? Great. Let me now give values to this a to understand it better. Let's take the negative a as minus 3. So suppose mod x equals to minus 3 is something that I have to solve. Mod x is the same V-shaped graph. So it's going to be here, 45 degree, 45 degree. And minus 3 is somewhere here, below the x-axis, right? Minus 3. So we're considering two functions, y equals to mod x and y equals to minus 3. Now, y equals to mod x is this graph. And y equals to minus 3 is this line, straight line. Is it intersecting anywhere? No, the concept remains the same. Absolute value cannot be negative. The range of modulus is positive real numbers. So hence you don't have any intersection here. But well, in case mod x equals to 4, then you will get an intersection. And let's see how and where. So this is x-axis. This is the graph of modulus V. And this time, the second graph or the second function we are interested in is y equals to 4. Suppose this is 4. So y equals to 4 somewhere here, right? This line. And what's going to happen? It's going to cut the graph at 2 points. And what are these 2 points? The height is 4. So you would see that modulus x equals to 4 or y equals to 4 when x is minus 4 or 4. So you have exactly 2 solutions here, minus 4 and 4. These are the 2 solutions. So that's what is dealing with absolute value equations, okay? Let's increase the intensity of the question now. Let's now look at modulus of 3 minus 2x equals to minus 8. So if I would have given you mod x equals to minus 8, you by now know that this cannot have any solution. What about mod of 3 minus 2x equals to minus 8? Will the situation differ here? Well, so we have 2 functions to care for. One is y equals to mod of 3 minus 2x, and the other is y equals to minus 8. Let's try and graph mod of 3 minus 2x. By now, we know how to graph modulus functions. I'm assuming that you've done that video with me. So you can put this equal to 0, and that gives you the point 3 by 2. So this is what the graph would look like. When x is equal to 3 by 2, y is equal to 0. When x is 0, y is equal to 3. And when x is 2, not 2, it's 3, then also y is equal to 3. So this is what mod of 3 minus 2x will look like on the graph. And the second function that we're interested in is y equals to minus 8. Well, y equals to minus 8 is a line which is somewhere out here. You still do not have any intersection, and the logic remains the same. Absolute value, no matter what is inside, absolute value has to be greater than or equal to 0. So how will it equate to a negative number? That's just not happening. Okay. So again, we have a situation of no solution in this case. But yes, when 3 minus 2x is equal to 0, what is happening then? I'm going to make use of this graph itself. In that scenario, what are we saying? We're saying the other concerned function is y equals to 0. That means we're here. And that gives me a unique solution. In this case, I will have a unique solution. And that's going to be x equals to 3 by 2 or 1.5. That's the vertex tip here. Okay. And in case mod 3 minus 2x is equal to 6, what's going to happen then? Let's graph it again. So we have two functions of concern here. Mod 3 minus 2x is one function and y equals to 6 is another. So, well, the graph looks something like this. It's V-shaped, cutting the y-axis at 3, and again 3 here, and at 1.5 or 3 by 2, it is touching the x-axis. And what are we saying? We're saying y equals to 6. Y equals to 6 is happening somewhere here. Y equals to 6 is happening somewhere here. Well, you will have to figure out the value. Graphically, the value that I can see is minus 1.5 and 4.5, but we can algebraically also try to figure it out. And that's what I'm going to teach you now. But what we know here is that we have two solutions because we have two intersections. So we have two solutions here. Well, graphically, I can see it's minus 1.5 and 4.5. Let's check this algebraically. We are interested in mod of 3 minus 2x equals to 6. Now, let's talk in layman terms. Mod y say is equal to 1. When do you think the absolute value of something will be equal to 1? Well, the absolute value of minus 1 is equal to 1 and the absolute value of 1 is also equal to 1. So when you have to solve this kind of expression algebraically, what you know is that there are two scenarios. If whatever is inside is positive, then also it needs to be equal to 6. The absolute value is equal to 6. Or if whatever is inside the modulus is negative, then also the absolute value is turning out to be 6. So what I can say is that two things are possible. Either 3 minus 2x is equal to 6 or 3 minus 2x is equal to minus 6. Under both the scenarios, I'm going to get the absolute value as 6. Okay. So solving this now, you will get 3 minus 6 equals to 2x. Or in other words, minus 3 by 2 is equal to x. Or 3 plus 6 is equal to 2x. Or 9 by 2 equals to x. In other words, we have the same result. Minus 1.5 equals to x. 4.5 equals to x. So, in other words, when either your x is, whenever your x is minus 1.5, this equation will give you 6. Or this equation is happening at minus 1.5. And also this equation is happening, or this equation is viable, this equation is true when x is equal to 4.5. Under both the scenarios, this is happening. Similarly, you can work with other questions now very easily. If you have to solve for modulus of 2x plus 7 equals to 5, what do you have to do algebraically? So you're saying that modulus of this term is equal to 5. This term, in case is equal to minus 5, then also the modulus will give you 5. Or in case this term, it's negative of it. If you have a negative of it inside, then also you will get 5. That means that if this term is equal to minus 5, then also the absolute value will be 5. So it's happening when 2x plus 7 is equal to 5, and it is also happening when 2x plus 7 is equal to minus 5, then also the absolute value is 5. Solving for it, you will get that x is equal to minus 2 upon 2, that is minus 1. And the other one will be that x is equal to minus 5 minus 7, that's minus 12 by 2, that is equal to minus 6. When x is equal to minus 1, when x is equal to minus 6, you will get that the absolute value of this is equal to 5 indeed. And now your homework is that try this out graphically. Please create the graph of mod of 2x plus 7 and see the intersection of that with the graph of y equals to 5. Thank you very much.